Okay, let's talk about Lewis symbols and ionic bonding. So first, here's some examples of Lewis symbols. Let's talk about kind of the basic structure of Lewis symbols. So they always consist of an element symbol that's going to represent the atom's core. Okay, so whatever element you're talking about, you use the element symbol, and that represents, the nucleus and all of the core electrons, so the inner electrons. And then you have dots around that symbol. Those are representing our valence electrons. Now, occasionally you might end up with, when you're doing structures, with one element that doesn't have any dots around it, say when you have an ionic compound, but then in that case, it's going to have some sort of charge on it. But in general, you're going to have always at least some dots around your element symbol. At least if you're dealing with a neutral atom, you would have some dots. Now, with this, we're going to get to bonding and start talking about how atoms bond. And using Lewis symbols, it can kind of help to predict how something is going to want to bond. And that's because most atoms are going to want to achieve an octet of an electrons. Okay, that's what's called the octet rule. So having an octet of valence electrons, or 8 valence electrons, is especially stable. Okay? And so all of the noble gas elements, all the atoms of noble gases have 8 valence electrons, and they're very stable. They're at a very kind of low energy state in having those 8 electrons. So for instance, like neon, what I have here at the very bottom right. And so that's favorable. So everything kind of wants to get there in some way. So one way that they could do that is by losing or gaining electrons. And so you have some elements that have very few valence electrons, and those generally will just want to lose those electrons because then they just have their inner core, which is already filled up. And so that makes it stable. Or you have some elements that just need a few more electrons, to actually become stable. So then they will either take on electrons from something or share electrons in order to obtain that octet. But sometimes that's not even possible. They can't lose enough to go down to their core, or they can't gain enough to get that octet. So sometimes things will just form enough bonds to deal with their unpaired electrons. Okay, so when you're drawing a Lewis symbol, you put the element symbol down, but then you put dots around it to represent the valence. But when you do that, you should always kind of think of the element symbol as having 4 sides. So it has a left, a right, a top, and a bottom. And you're going to place dots on each of those sides individually first. Okay, so unpaired electrons. And then once you have one on each side, kind of like what I have there for carbon, right? Well, carbon only has 4 valence electrons. You can see it's in group 4 on the periodic table, so it has 4 valence. And so it's got a single dot on each side, okay? But then if you go on to the nitrogen, nitrogen's one more over on the periodic table, so it has 5 valence. So once we need to place that 5th dot, we pair it with one that's already there. Okay, so on nitrogen, you have a pair and then 3 by themselves. And so when you see these individual electrons, that gives you an idea of how many bonds something would like to form. So like lithium's got 1 unpaired, so it would like to form 1 bond if it's going to form a bond. And beryllium's got 2, so it would like to form 2 bonds, and so on. So each unpaired electron typically is where something's going to want to bond, because it wants to pair that electron at the very least, okay, if not obtain an octet, okay, or somehow get rid of that to obtain an octet. So sometimes people call that the valency of an atom, how many bonds it would prefer to form, and that's based on unpaired valence. Um, but it can be more complicated than that. When you're looking at full structures, sometimes things will form a different number of bonds than what you might predict from the Lewis symbol. So that's just a starting point to give you a general idea. So like neon's got 8 dots around it, so it already has an octet. It doesn't have any unpaired, so it doesn't really want to form any bonds, okay? And so Lewis symbols, they give you a little bit of information, but we don't draw them a lot. You could also draw a Lewis symbol of an ion. Say, for instance, lithium. Lithium, when it forms an ion, so it forms lithium ion, it's going to be Li plus, okay? And it does that by losing that electron. So the Lewis symbol for that is simply Li plus, because you take the dot off and then you indicate the charge, okay? Whereas something like fluorine, when it forms an ion, it forms the fluoride ion, so F minus. And how it does that is by taking an electron from something. So if you were to draw the symbol of that, then what it really would be is you have your neutral fluorine atom, right? And it gains an electron, so it gets an 8th dot there. And then we usually put that in brackets and put a negative. Okay, so that would be the Lewis symbol of fluoride ion, whereas lithium ion, it just has no dots in the charge. Okay, so it depends on what happens to it. So Lewis symbols are representations of either neutral atoms or ions of just one atom. Okay, so we don't use them a ton. They can be useful just to understand kind of how things bond, or sometimes it's helpful in thinking about ionic compounds. But, oops, most of the time we draw what we would call Lewis structures. And so that's where you have lots of things, not just one atom. Okay. So let's talk about ionic bonding. Okay. Ionic bonding is when you have electrons transferred from one thing to another. Okay, so typically it's you have a metal, you have a nonmetal, and the metal gives electrons to the nonmetal. So you end up forming a cation and anion, and then those cations and anions are attracted by electrostatic forces. So that's what ionic bonding is. Now, if we wanted to represent this using Lewis symbols and overall a Lewis structure for the compound, then what I would suggest when you're trying to figure this out is you would draw the neutral elements first. So let's say we're dealing with, let's do calcium chloride, and so CaCl2. If we wanted to draw the structure for that, well, first I would draw the neutral atoms. And so we have calcium, and that's Ca, and it's group 2. So I would put 2 dots on it because it has 2 valence. And then I would draw chlorine atoms. Okay, we have 2 of them, and each one has 7 valence. So I would put 7 dots around it. And then I'd do the same on the other one, 7 dots around it. And so each of those is missing an electron, and calcium's got 2 electrons it would actually like to give up. So what happens is the calcium will give 1 electron to one chlorine and 1 electron to the other chlorine. Okay, so this is what happens first, and what you get then is calcium with no electrons, so it has a 2+ charge. And then you have 2 chlorine atoms, okay, which actually now each have 8 electrons on them, and each have then a negative charge. And so we would have a symbol for each one of those. Okay, so all three of those things come together and are our overall Lewis structure for the ionic compound. So you can kind of arrange those however you want. Sometimes people will write that as Ca2 plus, and then next to it they'll put 2 in front of just one of these Cl minuses. Okay, so instead of drawing that Cl minus twice, they might just put a 2 in front saying that there's 2 of those. But there's no line connecting those things, because when we do draw Lewis structures, lines indicate shared electrons, and none of these electrons are shared. They're actually given from one thing to the other. So either this over here or this here is the Lewis structure of the ionic compound calcium chloride.